So we're going to talk about Newton's first law. Okay, so this law says that the summation of the forces in the x direction is equal to 0, and the summation of the forces in the y direction is equal to 0. And this happens when a particle is moving with constant velocity. The velocity is constant, okay, or when the particle is at rest. And this is okay because acceleration is going to be delta v over delta t, which is final velocity minus initial velocity over delta t. But if the final velocity is equal to the initial velocity, that means that acceleration is final velocity minus final velocity over delta t, and that's going to be equal to 0. So the first law could be applied for a particle that is either at rest, okay, or moving with constant velocity. So if either one of these guys happens, if the particle is at rest or moving with constant velocity, the summation of the forces acting on that particle has to be equal to 0 in the x direction, and the summation of the forces in the y direction have to be equal to 0. Okay, so here, let's do an example of this. So if we have here, okay, let's get a new one here, clear the drawings. Let's say we have, okay, let's say we have a particle here. So we have a particle which is hanging from the ceiling. So this is your ceiling right here, okay? And then, okay, you have something like this. You have here and here, and then you have a cord here, and you have another cord here. And okay, let's get this one better. So if we have a system which is hanging from the ceiling, in this case, we have a box here, and this is our box, and it has a mass, let's say a mass of 1 kilogram. Okay, it's 1 kilogram, the mass right there. Okay, and we have here an angle, and this angle is going to be 45 degrees. And we have here another angle, and it's going to be 45 degrees. So we can see that we have this one, which is we're going to call tension 1, and this is going to be tension 2. And this one has a weight. The weight is going to be coming this way. Okay, that is the weight. So we can apply the first law here. We can apply the first law because nothing is moving. So this system is at rest. So our system is at rest. In that case, the summation of the forces in the x direction have to be equal to 0. And the summation of the forces in the y direction have to be equal to 0. So you will have to apply these equations of motion for our particle that is completely at rest. Okay, so let's do the body diagram. So we could do our body diagram right here. So let's pick another color for the body diagram, and it's going to be right here. So we're going to do the body diagram right there. And we can see here, if we use geometry, that if we trace these lines right here, and then we trace another line this way, okay, we can see that this angle is equal to this one, okay? So that means that this angle here is going to be the same. So this is going to be 45 degrees, and this one is going to be 45 degrees. So because this one here is 45 degrees, and this one here is 45 degrees. So that's what's happening here. So we can say that we have a tension coming this way, and we have another tension coming this way. Okay. And this would be a vector, and this would be a vector, and we can call this tension 1, and we can call this tension 2, and this angle is going to be our 45 degree. So this is going to be 45 degrees, and this one is going to be 45 degrees. Okay. And we have another vector, which is a vector that's coming this way. Okay, this vector here. And this one is the weight, and the weight is going to be mg, and that's going to be the weight. So what we have here, let me get rid of this one, it's kind of in the way. Okay, so this is going to be the mass over here, and it's 1 kilogram. Okay, and we have here 3 vectors. So we have to break down these vectors. This one is going to have a component that goes this way, and this one is going to have a component that goes this way, and the other one is going to have a component that goes this way and has another component that goes this way. Okay, so T1 has to have 2 components, which is going to be, the components are going to be T1 cosine of 45 degrees, and the other one is going to be T1 sine of 45 degrees. And the other vector, this is going to be T2. It's going to be negative. So it's going to be T2 cosine of 45 degrees right here. And this one is going to be T2 sine of 45 degrees. Sine of 45 degrees in the y direction, and T2 cosine 45 degrees in the x direction. And we have to add those. So let's add those vectors. So we have that the summation of the forces in the x direction is going to be T1 cosine of 45 degrees, minus T2 cosine of 45 degrees. That's going to be equal to 0 because we're going to follow this law. And the summation of the forces in the y direction is going to be T1 sine of 45 degrees plus T2 sine of, let me give it more space here. Okay, so it's going to be, okay, let's do it over here. So the summation of the forces in the y direction is going to be T1 sine of 45 degrees plus T2 sine of 45 degrees minus mg, and that's going to be equal to 0. So we do have our equations right here. We have these equations that are the equations of motion. Okay, and now we can say that, okay, we can say that let's go with equation number 1. This would be equation number 2 right here. So let's solve equation number 1 over here. So we're going to do equation number 1. And we can say that T1 cosine of 45 degrees is going to be equal to T2 cosine of 45 degrees. So we can cancel these out. So we can say that T1 is equal to T2. That means that this is going to be equal to T. So we don't need the sub-indexes anymore. There's no reason to be there because T1 is equal to T2. So we can just use T. We can just use T there. In that case, we go to the second equation. So let's go to equation number 2. And we can say that T sine of 45 degrees plus T sine of 45 degrees is equal to mg. Okay, so this is going to be 2T sine of 45 degrees, and that's equal to mg. Okay, and we can divide all this by 2 sine of 45 degrees. Over here, we do the same thing, 2 sine of 45 degrees. So this cancels with this, and this cancels with this, and we got that T is going to be equal to mg over 2 sine of 45 degrees, 45 degrees right there. Okay, so let's say that G is going to be 9.8, but let's approximate it to 10. So this is going to be 1 kilogram here, and this is going to be 10 meters over second square, because that's the G, and this is going to be a 2, and this is going to be square root of 2 divided by 2. So we can calculate the tension. So this 2 cancels with this 2, and we're going to have 10 over square root of 2 kilogram meter over second square. So our tension is going to be equal to 10 over square root of 2 newtons, because the Newton, here I'll put it over here, the Newton is defined as kilogram meter over second square. So the tension, we have found the tension in chord 1. We can put it over here. Tension 1 is equal to 10 over square root of 2 newtons, and tension 2 is the same thing. So tension 1 and tension 2 are going to be 10 over square